Hi everyone, the Kenyan teacher here. Hope you are doing well. Pleasure to present 2022 KCSE Chemistry Paper 2. This is question number 4, testing on rates of reactions and reversible reactions. Welcome as we present the expected responses to question number 4. Part A. State and explain how a catalyst affects for Roman 1 rate of a reaction and for Roman 2 yield of products. We begin with part 1. And for part 1, we know that a catalyst actually increases the rate of a reaction. A catalyst increases the rate of a reaction. This increasing the rate of a reaction would earn ourselves the first mark. And then we go ahead and explain how. So, a catalyst increases the rate of a reaction by lowering the activation energy. For the next mark, giving a total of 2 marks for question 4A, Roman 1. We proceed to Roman 2, where we are supposed to state and explain how a catalyst affects yield of products. And here we know a catalyst actually has no effect on the yield. This is only 1 mark, so no effect for that 1 mark. We proceed to question 4, part B. Rates of reactions are measured using various methods. In the decomposition of hydrogen peroxide, of course, we shall obtain oxygen gas. The rate is measured by recording the volume of oxygen gas produced with time. Other than measuring volume of gas produced, we are asked to describe a method that can be used to measure the rates of each of the following reactions. B Roman 1, we are reacting sodium thiosulfate with hydrochloric acid. So in this reaction, where sodium thiosulfate is reacted with hydrochloric acid, we can measure the rate of that reaction by taking note of amount of sulfur that would be deposited in a given time interval. So for this question, we would measure the rate by reacting the hydrochloric acid with sodium thiosulfate. Of course, in a beaker. This beaker, we shall place it on a cross. Once we do that, then we will then be able to record the time it takes for the cross to be obscured or to disappear. So it is 2 marks. Placing that beaker on a cross, the first mark, and measurement of time that it takes for the cross to be obscured, the next mark. There is an alternative here where we shall place a mixture. We shall place a mixture of hydrochloric acid and sodium thiosulfate. on a balance or any weighing machine. After this, we are supposed to record the mass. We are supposed to record the mass of this beaker and its contents after a given period of time. So these can also be able to tell us the rate of the reaction between hydrochloric acid and sodium thiosulfate. So for students who would think of measuring the mass, putting a mixture of HCl and sodium thiosulfate on a balance would earn ourselves the first mark, and then recording the mass after a given period of time, the next mark. To the next reaction, we are told to state a method that can be used to measure the rate of a reaction that involves acidified potassium manganate 7 with iron 2 sulfate. So here we are going to measure the time. We are going to measure the time it takes for the color change from purple to colorless. So we shall measure the time it takes for the purple color to change to colorless for one and only mark for that section. We then proceed to part C of question number 4. So for part C, we are told in an experiment, the rate of decomposition of 50 cubic centimeter of hydrogen peroxide in the presence of manganese 4 oxide was measured. We have figure 3, which shows the results of the experiment. So on the y-axis, we have volume of oxygen produced, and on the x-axis we have time. So this curve was drawn over a period of about 37.5 seconds, and we can see the maximum volume of oxygen obtained was about 112 cubic centimeters. So with that, we are supposed to use the graph now to answer the questions that follow. We begin with part 1, and part 1 is asking us to write the equation for the reaction. So here we were able to decompose our hydrogen peroxide, which was in aqueous state, and we are able to get water and oxygen gas. Of course, we balance with a 2 on hydrogen peroxide and 2 on water. Getting the wrong states would deny ourselves half a mark, and a student also had the option of putting your manganese 4 oxide on the arrow. It's not a must to be put, but if you put it, kindly make sure that the formula of our catalyst is correctly written, manganese 4 oxide. Let's proceed to the rest of the questions concerning the graph. So the next question is asking us to use the graph to determine the maximum number of moles of oxygen produced, and we are told the molar gas volume at RTP is 24 cubic centimeters. So we shall get back to our graph, and as already been indicated, we can see the maximum volume of oxygen that was obtained. If you read the section where the curve flattened out, you realize that the volume here coincides to 112 cubic centimeters based on the scale that was given. So we are supposed to use that volume to help us calculate number of moles. So to answer our question, we know that 24,000 cubic centimeters of oxygen gas at room temperature and pressure is equivalent to 1 mole of it. From our graph, we only obtained 112 cubic centimeters. So how many moles would that be equivalent to? If we do cross multiplication, we have 112 multiplied by 1 divided by 24,000. And if we work that out, we should get a figure of 0.0046667 moles. It is worth 2 marks. So a half a mark for reading the graph well to obtain the maximum volume of oxygen that was produced. Division by 24,000 would give 1 whole mark, and the correct answer, the last half, giving us a total of 2 marks. For part 3, we are now asked to calculate the concentration in moles per liter of hydrogen peroxide. So here we will be forced to kind of recopy or rewrite our equation for the decomposition so that we are able to get the mole ratio between oxygen and our hydrogen peroxide. So moles of oxygen are here. We are asked moles per liter, that is molarity of hydrogen peroxide. To get the answer here, we need to start by getting moles of hydrogen peroxide that were produced. And you can see from the equation, the mole ratio is 2:1. So we begin with that. Mole ratio between hydrogen peroxide and oxygen is 2:1 as per our equation. With that, we can get moles of hydrogen peroxide that were used. It is simply moles of oxygen, which are here, multiplied by 2. So we shall have 0.004667 multiplied by 2 to give us 0.00933. These are moles of our hydrogen peroxide. Now, concentration in moles per liter would mean the number of moles in a liter. This number of moles here are for the volume of hydrogen peroxide that was used. And this volume has been specified in the stem of the question. We are told that in an experiment, the rate of decomposition of 50 cubic centimeter of hydrogen peroxide was measured. So the volume we used was 50, and we shall use that to help in working out the concentration in moles per liter. So argument would be that if 50 cubic centimeter was able to be equivalent to 0.00933 moles, how about a liter of solution? So if you do cross multiplication, we would have 1000 multiplied by 0.00933 divided by 50. And we get our concentration in moles per liter as 0.1868 molar solution. It is 2 marks, so half a mark for getting the correct moles of hydrogen peroxide. 1 whole mark for multiplication by 1000 and division by 50, and a half for the correct molarity. Part 4 is asking us to determine the rate of decomposition at 18th second. So we shall get back to our graph, and here we are. We are supposed to approximate 18th second on the x-axis. And if you look at our scale, between 0 and 5, we have 10 small squares. So it means every small square represents half seconds. So with 15 here, we shall just count 1, that is 15 and a half. Next, 16, next 16 and a half, next 17, next 17 and a half, and then next would be our 18th second. So we follow it up to our curve, and then at that point, because this is what mathematicians would call instantaneous rate of change, we are supposed to draw a tangent that touches the curve only at that point. And then to get the rate, therefore, we would do change in y over change in x. And according to my tangent, we have a point here which is 27 and a half by about 118. Of course, when you do yours, you'll get different coordinates. Then here, I have about 7 and a half for the x and around 72 for the y. So armed with these two coordinates, we can easily get the rate of change. And therefore, to answer our question, we would actually write that rate is given by change in y over change in x. According to the way I've drawn my tangent, we have the change in y would be 118 minus 72, and change in x would be 27 and a half minus 7 and a half. When I do this, I'm able to get 46 by 20, and that gives me a rate of about 2.3 cubic centimeters per second. Of course, your answer need not to be the same as mine, as long as you follow the correct working and you have different sets of coordinates. Your answer is as good as mine. So a half for the subtraction for y and x, and a half for the answer. We proceed to part 5, and we are told to state and explain one factor that would increase the rate of decomposition of 50 cubic centimeter of our hydrogen peroxide. The first factor that we can have is increase in temperature. For the first half mark, we are told to explain, state and explain. So we've stated that increase in temperature would increase the rate of decomposition. How? This is by increasing. So increasing the temperature increases the kinetic energy of the molecules. So they'll be able to actually have higher kinetic energy, and this would lead to faster collisions, and therefore the rate of reaction would increase. That is one mark. A candidate had an option of also giving us the other factor, and the other factor would be increase or increasing the concentration. We can increase the concentration of the hydrogen peroxide. That would earn the first half mark, and then we go ahead to explain that increase in concentration of hydrogen peroxide leads to higher frequency of effective collisions of hydrogen peroxide molecules with those of the catalyst, and that is manganese 4 oxide. So increase in concentration of hydrogen peroxide, half mark, leading to higher frequency of effective collisions, another half mark, total 1 mark. Dear candidates, that is question number 4 testing on reaction rates and reversible reactions. We wish you all the best and keep it the Kenyan Teacher for more insightful reviews.